All right, day 3 is box plots. A box plot uses a number line to represent the data visually. A box plot displays a data set along a number line using medians. And remember, medians are the middle numbers. Quartiles divide the data set into 4 equal parts. The median or second quartile divides the data into 2 halves. The median of the lower half is the first quartile. The median of the upper half is the third quartile. The inner quartile range is the difference between the first and the third quartile. So looking at this box plot, this is our least value. This is our greatest value. Here is your third quartile. Here is your first quartile. And this right here is your median of the entire set of data. So for example, if we're reading a box plot, and here's our box plot right here, it says below is a box plot showing the ages of the U.S. women's basketball team. It says, what is the oldest age of the person on the team? Well, that would be this right here, which would be 30. What is the youngest person on the team, which would be this right here, which would be 18. It says, what is the median of the data, which is our middle number, which is right here, which is 25. Then it says, what is the first quartile, or our lower quartile, which would be this number right here, which is 23. It says, what is the third quartile, or the upper quartile, which is this number right here, which is 29. And then what is the interquartile range, which is the difference between the first quartile and the third quartile. So it's the difference between the 29 and the 23. And that number would be 6. Now it says, what is the range of the data? Now remember, the range of the data is the difference between the highest number and the lowest number. So our highest number is 30. Our lowest number is 18. So our range of data is 12. So our next example is example number 2. And here we're dealing with math scores. I'm going to bring this up just a little bit. It says the following is a box plot of math scores. Now it says, what is the median or middle of the data? Well, here, notice, here's 78, here's 80. So that number is in between the two here. So that number would be 79. It says, what is the first or the lower quartile? So here's 74, here's 76, so that number would be 75. Our third quartile, or our upper quartile, would be, here's 82, here's 84, 86, so our number would be 85. The lowest math test score here would be 72. Let me move this up just a little bit so I can write on here. So it would be 72. Our highest math test score would be 88. Then our inner quartile range, so the difference between our upper and our lower, would be 85. Minus 75 would be 10. And our range would be the difference between our highest and lowest numbers, so it would be 85. Oops, sorry, let me erase that. Would be the difference between the 88 and the 72. So in this case, it would be 16. So now interpreting a box plot when we're reading it. So it says, what does box plot tell you about the data? Well, here we have a box plot about height in inches. So it says the left whisker, this here, right here, is longer than the right whisker. And here's our right whisker here. And you can see that the one side's longer than the other. So the data is more spread out below the first quartile than above the third. And then it says the range of data is 22 inches. In other words, 72 minus the 50. So here we can see different shapes of the box plots and what they mean. So for example, if it's skewed left, in other words, the left whisker is longer than the right whisker. That means most of the data are on the right side of the plot, okay? Most of that data here is on the right side of that plot. Next, we have symmetric, okay? The whiskers are about the same length, and the median is in the middle of the plot. Notice that the median is about right in the middle there. Okay, notice it's about right in the middle. And then the third one that we have, you guessed it, skewed right. Okay, that means the right whisker is longer than the left, and most of the data is on the left side of the dot plot, or box plot, sorry. Okay, so now, if we're looking at our example, so for example 1, we have below is a graph of the number of discount department stores selling camping and backpacking equipment in the U.S. Well, what does the box plot tell you about the data? Well, it's going to tell us, one, that it's skewed. When we're looking at this, it's going to tell us how it's skewed. And first of all, this is skewed right. The box plot which means most of the data is on the left side, of the plot. Okay, notice how the right whisker is a lot longer than the left. And if you notice that our median is more towards the left side. Okay. It says, what is the median of the data? Well, if you notice, I have to kind of guess just a little bit here. If I bring that median down, it's about 49. And actually it's about 48 to 49. Now here we could use a range. Okay, because you do have to guess just a little bit, okay? And because it's not perfect, okay? So you can have a little bit of a range, okay? All right. Next. So for example 2, here it says below is a box plot of test scores for 9th period. Okay. And it says, what does this box plot tell you? Well, for us here, this box plot is going to tell us the box plot is skewed left in most of the data is on the right side of the plot. So if you notice, most of the data is over on the right side of the plot. And notice how long that left whisker is. Okay? So it says, what is the median of the data? Well, the median of our data is right here, and that's 88. The next thing it wants to know, or the next thing the question is asking us, is what is the range of the data? So the range of our data is 102 minus 38. So in this case, it's going to be 64 is going to be our range. And then what is the interquartile range, which is going to be the difference of 96 and 72, which in this case is going to be 24. This ends the lesson of our box plot.